So for today's lesson, we're going to look at how we can determine the magnitude of the contact force. The contact force occurs when you have two or more blocks that are pushing against each other. Let us say, for this example, that we have two blocks M1 and M2. They are different masses. For example, 20 kilograms for M1 and 40 kilograms for M2. They're roughly half and double the size of each other respectively. Let us now say that this system is now being pushed from the left to the right with a force that is 300 newtons in magnitude. So now what's going to happen is we're going to experience a contact force where these two blocks meet. The contact force is equal and opposite in magnitude, and they're felt by M2 when M1 is exerting a force onto M2, M1 is being pushed against M2, that force is called the contact force. Vice versa, M2 is resisting that push from M1 and is resisting in the same equal and opposite magnitude force, which is also, of course, the contact force. So this is the force that we're trying to find. So there are three steps. The first step to this is we want to find the acceleration of the entire system. We want to find how much this entire system is moving. To do that, we do our classic F equals ma. In this case, it's the net force experienced by this entire system. So we know what F net is. F net is the input force that we're putting in from the left-hand side, which is 300 newtons. Mass, in this case, because we're considering the entire system as a whole, is the sum of the two masses, the two blocks together. So we get m1 plus m2 times acceleration. Now we know, of course, what m1 and m2 is. So it's 300 equals 20 plus 40 times acceleration. And we can, of course, rearrange to solve for this. 300 over 60 equals 5 meters per second. So this is the acceleration that this entire system is moving towards the right-hand side. M1 and M2 are both accelerating at F equals ma, a equals 5 meters per second. So they're both accelerating at 5 meters per second. Great. Now, there are a few ways to go about this. I'll show you first the easiest way to do this with two blocks. With two blocks, we go immediately to the block furthest from the input force. In this case, it's block M2. It's furthest to the right. The input force is from the left. So let's just consider force M2. And we're going to do F equals ma on just this block. Just this block. So F2 equals the mass of the second block, which of course is 40 kilograms, times the acceleration, which is 5. Which equals 200 newtons. Great. So if we put the 200 newtons into the diagram here, this block here is moving to the right with a force of 200 newtons. Great. So it just so happens that this is the contact force. Why? So let us go back and do a sanity check. So if what I'm telling you is true, we should be able to get to the same answer by considering the first block, M1. So let's do that. For M1, let us consider it by itself. The force that is experienced by M1 is not as simple as M1A. It's not as simple as this. Why? Let's draw the free body diagram. This is force M1, block M1, which is 20 kilograms. It experiences a force in the right-hand direction of 300 newtons, but it's also experiencing a force in the left-hand direction, which is the contact force. This is the force that M2 is resisting that push with. It's pushing back. So the net force for this free body diagram is actually 300 newtons minus the contact force. If we define this direction as the positive direction, then 300 newtons minus the contact force is what we should be using. So, great. We know if the net force of any body is F equals ma. So we can substitute ma into this equation, 300 newtons minus the contact force. We know what m1 is, we know what acceleration is, so let us substitute that in as well. 20 times 5 equals 300 newtons minus the contact force. So we can rearrange to solve, and of course move the contact force to the left. 300 minus 100 equals 200 newtons. So we see here we get 200 newtons, of course, going in the leftward direction. And if we put that back into our diagram here, up here, we will get 200 newtons moving to the left, which is equal to the 200 newtons moving to the right. And of course, like I said earlier, these should be equal and opposite, so we know that this is correct. Now there's another way of doing this, which might be more easy if we use more than 3 blocks, but I will, for the sake of example, give it to you here anyway. Let us draw this diagram again. We have block M1 and we have block M2. Actually, let me move that further down. We have block M1 and we have block M2. And they are the same mass, 20 kilograms and 40 kilograms. And they have the same input force of 300 newtons from the left to the right. Now we know that this thing is accelerating, the system is accelerating at 5 meters per second. We can actually see the equation up here that we used. So now, instead of going to the right-hand block first, now let's do F equals ma for each block individually. F1 equals m1 of A, which of course is 20 times 5 equals 100 newtons. Right? So this is experiencing 100 newtons in the rightward direction. For the second block, equals m2 times A, equals 40 times 5 equals 200 newtons. So this block is experiencing 200 newtons going in the rightward direction. Great. So now what is the contact force? So the contact force is simply 300 newtons minus 100 newtons. We have 300 minus 100 equals 200 newtons. And this here is the contact force. So we have here Fc equals 200 newtons. Great. Now you'll also notice that the 200 newtons is the same as the 200 newtons that the M2 block is experiencing. That's interesting. Now you realize that if we're at the last block down the line, there's no more blocks down here, then the contact force is simply equal to F equals ma for that last block. So that is why when I say we are using a 2-block system, we go immediately to the last block, the block furthest from the input source, because it only experiences one force, and therefore that force is equal to the contact force. And then we can work backwards. However, what if there's more than 2 blocks? So let's go to that example. Now we have 3 blocks. And it's going to get a little bit more interesting. And again, there are 2 ways of doing this. There's a general way, and there is a bit of a life hack sort of way. So we have 3 blocks, M1, M2, M3. And let's say that they are 15 kilograms, 30 kilograms, and 20 kilograms in mass. They experience a force pushing them from the left to the right of 130 newtons. So the first step again is we find the acceleration for the whole system. So we complete F equals ma for the entire system, which means we are adding up all the masses, 15 plus 30 plus 20 times the acceleration, which equals, of course, the input force, which is 130 newtons. So we can rearrange to solve for the acceleration. So it's 130 over 65, which conveniently equals 2 meters per second per second. It's almost like I didn't prepare this beforehand. So now we know the acceleration that each of these blocks are experiencing from the left to the right. So if we were to use this technique that I just explained here, let us find F equals MA for each block individually now. So for block number 1, we have F1 equals M1 times acceleration equals 15 kilograms times 2 equals 30 newtons. So there's 30 newtons going that this first block feels. For M2, we have F2 equals M2 times acceleration equals 30 times 2 equals 60 newtons. This this block experiences 60 newtons. And finally, M3, we have F3 equals M3 acceleration equals 20 times 2 equals 40 newtons. So there's 40 newtons for M3 here. Now, if we were to use the technique I used earlier to find the contact force between M1 and M2, what would we do? We would use 130 minus 30. Minus these two, we expect a contact force in here of 100 newtons. Great. Now, what about the next one? We have 100 newtons here. How would we find the contact force in here? Well, the contact force in here is actually not 130 times minus 60. It is now 100 minus 60. 100 minus 60 gives you 40 newtons here. And notice that I am not specifying which direction that the contact force here is working in, because they are equal and opposite. So this is 100 in this direction and 100 in this direction. Newtons, that is. Okay? So this is another way of doing it. And if you had another block over here and we wanted to find the contact force, then we would use 40 newtons minus whatever this was. In this case, this is the last block, it equals 0. But if it weren't, you would use the contact force, the previous contact force, minus the F equals MA for the individual block, onward and onward and onward. Well, this can get a little bit confusing if you forget which one you're supposed to be subtracting from what. Now, there are a few sanity checks that you can do to make sure you don't make any mistakes. The first is F equals MA for each block individually needs to add up to the input force. In this case, 30 plus 60 plus 40 equals 130 newtons. So we know that's correct. The second sanity check that we need to do is that the contact force plus all the forces before it also needs to add up to 130. So, for example, let me write this down on the right-hand side. We have 30 newtons plus the contact force right there, which is 100 equals 130 newtons. So up until that contact, that interface between M1 and M2, it should add up to 130. If we carry on, we should have, let me double check this here, we should have, let's see, 30 newtons plus 60 newtons plus 40 newtons equals 130 newtons as well. So we have F equals MA equals 30, F equals MA for M2 equals 60, that's 90 newtons in total, plus the 40, we get 130 newtons as well. So up until each contact point, then all the individual F equals MAs plus that contact force need to add up to the input force. This can get confusing. So what is the general way, the recommended way? The way where, if you're not sure, this way will work every single time. It's the following. We draw free body diagrams for everything. So let us redraw this again. We have a 15 kilogram mass. We have a 30 kilogram mass. And we have a 20 kilogram mass. They are experiencing a push from the left to the right of 130 newtons. Great. So, the correct way of doing this is we draw a free body diagram for each and every single block. Now, let's start with M1. M1 is the 15 kilogram block. It experiences a force that's pushing it to the right of what? of 130 newtons. In this case, we're just going to name this force F of M1, the force that M1 experiences. It also experiences a force that's pushing backwards from M2 and M3. They're resisting that push. This is the first contact force, right? There is a contact force here. That is the first contact force. Great. The second free body diagram is for the big M2 block, which is 30 kilograms. This experiences a force that's going forwards, and this is the contact force from block 1 and block 2, because there's a force, there's a force that is pushing this way from that contact. So that is the contact force between block 1 and block 2. And similarly, it is also experiencing a contact force going backwards because of the interface between the second block and the third block. So if we carry on as well, on the right hand side, we also have block 3, M3, which is 20 kilograms, which experiences, now this is a little bit tricky, but it only experiences one force going to the right, which is from the contact force over here between block 2 and block 3. So now the easiest we can already guess is going to be this last block. If we find F equals ma, the net force that this block experiences, it equals Fc2. That is the net force that is acting upon this block. Only one force. Now we know what the formula for net force is. It's M3a. Well, it's F equals ma. In this case, m is M3. So we have this beautiful equation. Let me just write that the other way around. Mc equals M3 times acceleration. Of course, acceleration we'll find by doing F equals ma for the entire system, which we did earlier. What did we find? F equals ma for the entire system, and then we get acceleration equals, let's scroll up here, acceleration equals 2 meters per second. So we know what the acceleration is for this entire system, because we did that. So we get 20 kilograms times 2 equals 40 newtons. Great. So we know that the contact force, the second contact force between blocks 2 and 3 is 40 newtons. Now let's go backwards. Let's start from the first block here. So for this block, we also want to look at what the net force is experienced by this block. Net force experienced by this block is the force that's going to the right minus the force going to the left, which just so happens to be 130 minus Fc1. Again, we know what F net is. F net is just F equals ma for this block. So it's M1a. And we can substitute in all the values that we know. So we get 15 times 2 equals 130 minus Fc1. Rearrange everything. We get 130 minus 30 equals 100 newtons. Excellent. We have 100 newtons there and 40 newtons and Fc2. My bad, this should be Fc2. So this equals 100 and this equals 40 newtons. Now we want to double check this. We should be able to get 40 newtons for either Fc2 or 100 newtons for Fc1 if we were to use the second block in the middle. So let us do that. The net force experienced by this block is Fc1 minus Fc2. Right? Now we also know what F net is. F net again, M2a equals Fc1 minus Fc2. Assuming we can substitute either Fc2 or Fc1 in, we will of course get, what is this, 30 times 2 is 60, equals, if we substitute Fc1 in, we'll get 100 here minus Fc2, so we'll get Fc2 equals 40. And of course, if we substitute Fc2 in, we should get 100 as the answer. It's not much of a sanity check, but, you know, if you're not getting that, something's definitely wrong. So now we know for sure that 100 newtons is the first contact force, and 40 newtons is the second contact force. Let us scroll back up to the first method we used. We have, very nicely, 100 newtons is the first contact force, and 40 newtons is the second contact force.